Alright, ladies and gentlemen, welcome to video number 2 on dilations in a coordinate plane. Ladies and gentlemen, you were supposed to take some notes on from the bottom of page 84. Before we get started with going over those notes, I'm just going to tell you real quickly. This is going to be an extended video. Sorry, it is what it is. And I'm telling you right now, of all the times it's so important, this is going to be one where you want to watch each slide, each example, by just watching and listening, and then when I'm done, you pause and you write it down and then move forward. Just listen to me, please. Just listen to me, please, and do that. So we talked about it a minute ago in video number 1, where I'd said, hey, it's going to mention it later, but I'm going to mention it now. And that was that the original figure and its image are similar when we have a dilation. When we have a dilation, the image and the original figure are similar. So, great. It also says that the ratio of the side lengths of the image to the corresponding side lengths of the original figure is called the scale factor of the dilation. Now, ladies and gentlemen, the book does not specifically, well, it does. It does tell you, but it tells a little bit later. I'm just going to do it now. Scale factor is K. So when you're done watching this slide, I want you to write this down and squeeze it in somewhere. You're going to write K. K is equal to the image to the original figure. That's the ratio. You start with the image and on the top, and you put the original figure on the bottom, and that becomes the ratio. Now, sometimes it will simplify and come out to a whole number, and that's okay. Anything over 1 is a whole number. So, ladies and gentlemen, here's where it said that right here. It said, to dilate a figure with respect to the origin, multiply the coordinates of each vertex by the scale factor, and here's where it showed you that scale factor is in fact K. So what does that mean when it says that? Putting it in algebra, you have these points right here, X and Y, and so to get the new image, you multiply the X coordinate by K and the Y coordinate by K to get the new coordinates. This is something that's really important to understand. Make sure you have it written down, make sure you start it. When K is greater than 1, when your scale factor is greater than 1, you have an enlargement. And when your scale factor is greater than 0 but less than 1, you have a reduction. Now, I just like to call it a scale factor of less than 1 because, ladies and gentlemen, you cannot have a scale factor that is negative. You can't do it. You cannot have a reduction or an enlargement that is negative. It just doesn't happen. So they tell you that K has to be greater than 0. It does, because you can't have a K as 0. That would eliminate everything altogether if you're multiplying, because anything times 0 is just that. So ladies and gentlemen, hopefully I helped simplify a little bit of this. Go ahead and write that other stuff in there if you haven't, and join me for our first example of video number 2. Alrighty, so finding the scale factor. It says the dashed figure is a dilation of the solid figure. Identify the dilation and find the scale factor. So I'm actually going to identify the dilation right away because I recognize that the dashed figure is smaller than the solid figure, which means that our dilation is a reduction because it's smaller. So we already know, ding, 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 we started, we talked about it. If we have a reduction, that means K is less than 1. We already know it has to be greater than 0. So K has to be less than 1. It's some kind of fraction because it's smaller. The original is always equal to 1. If you have K that's equal to 1, you have the same exact figure, right? That only makes sense. So let's talk about it. We know that K has to be the ratio of the image to the original figure. So that's what we're going to talk about right here, right now. So we have our image. I'm going to take side BC, this side right here. It's just easy to look at. And I'm going to count. And that's 1, 2, 3.5 units. And I'm going to write that as a decimal. So 3.5. And then I'm going to take the corresponding side length That's the original BC. I should have said B prime C prime for the image because that's technically what it's called. And the original image is BC. And when I count that one, 1, 2, 3, 4, 5, 6, oh, that's 7 right there. So 3.5 over 7. Some of you can instantly recognize that as having a scale factor that is equal to 1/2. So our scale factor is 1/2. Let's see how that works actually. So here I'm going to go to point B. So my coordinates of B are -5, 4. That's where B is located. If I multiply by my scale factor of 1/2, then what am I going to get? Well, at B prime, that will give me my new B prime coordinates. Half of -5, 1/2 times -5 is -2.5. And half of 4 is 2. And if I look at B prime is at -2.5 and up 2. So voila, it worked. You might want to pause, write it all down, and join me for example number 5. Here in example 5, again it says the dashed figure is a dilation of the solid figure, and we're going to identify the dilation and find the scale factor. So the first thing we're going to do is identify the dilation. And we can see that the dashed figure, the dilation, the image, is larger than the solid figure, so we know that has to be an enlargement. And we know enlargement, our scale factor is greater than 1. If it were equal to 1, we'd have the same exact figure, so it has to be greater than 1. All right, now when we want to find the scale factor, we're looking at this, and it doesn't seem to be as easy, because we don't have anything that goes horizontal or vertical when it comes to side lengths. So now we have to look at it doing it a different way. Kind of how I did it just a moment ago, except a little bit different. So we know that K has to be the image to the original figure. All right, so I'm going to go and I'm going to write down my image for J. What are my coordinates for J prime, rather? I'm sorry, J prime, right here, J prime. So J prime is at -3. Make sure you look at the scale on this coordinate plane and notice that it goes by 2's. So it's at -3 and up to 6. So my image is -3, 6 for J prime. Now I'm looking at my original J right here, which goes on the bottom. So J is located at -1, 2. Whoa. So now I have -3 over -1. And -3 over -1, it simplifies to what? That's right, 3. And 6 over 2, right here for the y coordinate, here was the x coordinate, -3 over -1 simplifies to 2. 6 over 2 simplifies to 3. So guess what our scale factor is? That's right, it's 3. Our scale factor is 3. Outstanding. Okay? So -3 over -1 does simplify to 3 over 1. And 6 over 2 does simplify to 3 over 1. Anything over 1 is 3. Because if you multiply -1 by 3, you'll get -3. And if you multiply 2 by 3, you will get 6. So we have an enlargement. Our scale factor is greater than 1. It's 3. Bingo. We got there. Moving on. Go ahead and copy this down and pause. And I'll see you in example 6. Here in example 6, it says, dilating the figure, we're actually going to do it. It says the vertices of the figure are given. Draw the figure and the image after a dilation with a given scale factor. Identify the dilation. So if you want to actually put the figure in with me, I'm okay with that. However, when we're done putting it in, you want to put your stuff down and watch. So our original figure, first of all, wait, what does it say? It says identify the dilation. Well, I'm going to do that first. Because this dilation is K, is 3. The scale factor is 3. That's greater than 1, so we know it's an enlargement. So when we're done drawing the image, it better be larger than this original one that we draw. So A is at negative 2, 2. Let's put this in here, A. B is at 1, 2. And C is at 1, negative 1. And of course, you would use your straight edge to draw a nice figure. Now, ladies and gentlemen, we're going to do our coordinates as we go. So our new coordinates for our image would be A prime. So we're going to take our scale factor and multiply it by both coordinates in A. So negative 2 times 3 is negative 6. And 2 times 3 is 6. So A prime is located at negative 6, 6. A prime. B prime, when we multiply 3 by each one of those coordinates, so 3 times 1 is 3, and 3 times 2 again is 6. So B prime is at 3, B prime is at 3, 6. Almost tripped myself up. And then we're going to C prime, and we're multiplying 3 by each one of those coordinates. So 3 times 1 is 3, and 3 times negative 1 is negative 3. So we go to 3, negative 3, bingo, and that's C prime. And of course, we're going to connect that. Bingo. Now, ladies and gentlemen, let's double check a couple things. Is our image larger than our original? Absolutely. Our original was ABC, and our, oops, I didn't put a prime on B. And our image is larger than that. So scale factor 3, it is actually 3 times larger. Going back to something we learned earlier, hey, if we take and draw a line through A prime and A, and then draw a line through C prime and C, and then draw a line through B prime and B, we would notice they all intersect at the point of dilation being the origin. How cool is that? All right, go ahead and grab your pencils, pens, mark it down after pausing the video, and meet me for our last example of the night. Welcome to example 7. In example 7, again, we're going to draw the figure of the vertices that are given, and then we're going to draw the image after a dilation with the given scale factor, and of course we're going to identify the dilation. I'm going to do that first. So our scale factor being 1/2, that's less than 1, that means we have a reduction. So our original is going to be larger than our image. Our image will be smaller. So you can write it down with me, and then after we're done, you want to put your stuff down and watch and listen, and then pick it up after you pause. So our original figure, D is at 4, 2. Here's D. And E is at 4, 8. F is at 8, 8. And G is at 8, 2. And then, of course, connect the dots with a nice fine line. You guys have your straight edge, and it's looking awesome. And then we're going to take and make our image by multiplying, oops, I wrote the wrong letter. I get in the habit of that ABC sometimes. So D prime, multiplying everything over here by 1/2. 4 times 1/2 is 2, and 2 times 1/2 is 1. So D prime is 2, 1. E prime, multiplying both of the original figure by 1/2. 4 times 1/2 is 2. 8 times 1/2 is 4. So 2, 4. E prime. And F prime, multiplying both by 1/2. Well, 8 times 1/2 is 4, and 8 times 1/2 is 4. So we're going to 4, 4. And that's F prime. And then G prime, multiplying both of those. 8 times 1/2 is 4, and 2 times 1/2 is 1. 4, 1 for G prime. And then, of course, draw that. So, our image is definitely smaller. Everything bingo. If, in fact, you were to take and draw a line through E and E prime, it would go through the origin. G and G prime go through the origin. F and F prime through the origin. D and D prime through the origin. They would all work if you did it correctly, because we are dilating on a coordinate plane based on the origin being the center of dilation. Ladies and gentlemen, Go ahead and pause this, write it all down, and then join me for your quick write. All right, ladies and gentlemen, I gave you a copy for your quick write. You need to draw the figure, the original figure, and then you're going to dilate it using the scale factor of 0.5. By the way, 0.5 is the same as what? That's right. It's the same as 1/2. Okay? So K is 1/2. What does that mean? Oh, it means that it's going to get smaller. Hey, ladies and gentlemen, and then we're going to do something else because we should be able to put all these transformations together. So after you dilate the figure, you're going to translate it, which means you're going to move it 2 units right and 3 units down, and then you're going to write your final coordinates. So your final coordinates should be A prime prime, B prime prime, C prime prime, and D prime prime. Whoop, I put too many primes on there. All righty, ladies and gentlemen, it's been an awesome night. I know it's been a long one. I know you're doing a fantastic job. Obviously, come to class with questions. You guys rock. We'll see you tomorrow.